In an experiment, 19 babies were asked to watch a climber attempt to ascend a hill. On 2 occasions, the baby witnessed the climber fail to make the climb. Then the baby witnessed either a helper toy push the climber up the hill or a hinderer toy preventing the climber from making the ascent. The toys were shown to each baby in a random fashion. A second part of the experiment showed the climber approached the helper toy, which is not surprising action, and then the climber approached the hinderer toy, which is a surprising action. The amount of time the baby watched the event was recorded. The mean difference in time spent watching the climber approach the hinderer toy versus watching the climber approach the helper toy was 1.12 seconds with a standard deviation of 1.93 seconds. Complete parts A through C. Part A. State the null and alternative hypotheses to determine if babies tend to look at the hinderer toy longer than the helper toy. So here our difference is hinderer minus helper, where mu hinderer is the population mean time babies been watching the climber approach the hinderer toy, and mu sub helper is the population mean time spent watching the climber approach the helper toy. Okay, so let's go ahead and think about the research or the alternative hypothesis first. Babies tend to look at the hinderer toy longer. So we're not just looking for a difference, so we know it's not going to be these not equal to's. So think about this. If we are expecting the mean hinderer to be bigger than the helper, right? So I'm taking a bigger number minus a smaller number. What kind of number do I get? I get a positive number. I get numbers bigger than 0. So that means that our difference here is expected to be positive. That takes some thought. I've got to think on that. And the only one that occurs on is F, where we have mu d is equal to 0, and then mu d is greater than 0 for H1, the research hypothesis. A little tricky. Again, how do we get that? The mean hinderer, we're expecting that to be bigger, as it says hinderer longer, so that time's going to be a longer time, minus helper. So we're hoping that that difference is indeed positive. Assuming the differences are normally distributed with no outliers, test if the difference in the amount of time baby will watch the hinderer toy versus the toy is greater than 0 at the 0.05 level of significance. Okay, we need to go run the stat crunch. Okay, we're going to go to stat, t-stat. Now, there is something for paired here, but that's really if you have the data already, and we're just given summary statistics. In fact, we're already given the mean difference, so there's no need to select that, right? Close out of that. But if you're given the raw data, that's where you go. One sample with summary. So what is our sample mean, standard deviation, and sample size? So we have the sample mean at 1.12 seconds, and then the standard deviation at 1.93, and we have 19 babies, so we got everything we need right there. And we're testing to see if this is greater than 0. Press compute. Okay, so we have our sample mean 1.12, we have our test statistic at 2.53, and our p-value at 0.01. So our test statistic was 2.53, our p-value to 3 decimal places, 0.011. Again, if you put 0.0105, I'll give you credit for that. Just let me know. Okay, state the conclusion. So what are we comparing this to? We're at the 0.05 level of significance. So we got to know, how low is low? What's considered low? It's sort of relative, right? And so we pick, before the experiment is run, we have to pick a level of significance, sometimes called the alpha level. In this case, it's 0.05. So it's lower than 0.05, that means it's low. We can reject HO. It's low, 0.01. So we do reject HO. There is sufficient evidence. So C. And so what do you think the result of this experiment imply about baby's ability to assess surprising behavior? I shouldn't have gone ahead and marked it, but there is enough evidence that babies have the ability to assess surprising behavior. That's what the experiment was trying to show, this part of the experiment.